In this video, we're going to look at how to find the end behavior of the zeros in the y-intercept for a function, a polynomial function, and then we're going to use those bits of information to sketch a graph, just kind of a rough idea of what the graph of the actual function would look like. Now our function in question is f of x equals x minus 1 multiplied by x minus 2 squared multiplied by x plus 1 squared. And we're going to start out by looking at the end behavior. Now there are two things we want to consider when looking at the end behavior. We want to look at the degree of the overall polynomial function, and we also want to look at the leading coefficient. So we need to figure out what each of those things are. Now I'm abbreviating leading coefficient as LC just so I have enough room for everything. So when you're looking for the degree, if your polynomial function is not in factored form, it's actually a lot easier. If it's all multiplied out, then you can just pick out the highest exponent and that's going to be your answer. Also, your leading coefficient would just be the coefficient of that highest exponent term. So this is not a problem whenever everything's multiplied out. But, unfortunately, our particular problem is in factored form. In other words, we can see clearly our factors, the x minus 1, x minus 2, and x plus 1. So what we have to do is we have to use a trick to figure out the degree and the leading coefficient. So what you want to do first of all, looking at the degree, is you want to look at any of your factors that are missing an exponent and go ahead and write a 1 in the place of that missing exponent. Whenever you've done that and all of your factors that involve an x have an exponent, then all you have to do to find the degree is add up the exponents. So we have 1 plus 2 plus 2, which is going to give us 5. And 5 is an odd number. That'll be important when we make our conclusion here in just a second. So next you want to figure out what the leading coefficient is. And so if you don't have a number in front of your x terms, you can go ahead and write a 1 as your leading coefficient in front of each of those. And what you have to do is you have two options. You can either FOIL everything out, which is going to take forever since this is a 5th degree polynomial, or you can just multiply out the leading numbers that are connected with all of your x terms in a situation like this. And so what we can do here is we can take all of these 1s and multiply them together, of course keeping in mind that this exponent of 2 would have to be applied to the 1 in each case. So if it was a number besides 1, this would take a little more time. But ultimately what you want to do is you want to multiply all those numbers out and see what you get. And so here we just have 1 from this factor right here multiplied by 1 squared multiplied by 1 squared from those factors. And that's going to all boil down to just giving us positive 1. Now all we really care about is whether this leading coefficient is positive or negative. So it's not super important that you're able to get the actual number. We just want to know whether it's positive or negative. And in this case, of course, 1 is positive. And that gives us all the information we need to be able to figure out what the end behavior, in other words, what happens as we go to the left or to the right ultimately, is going to be. So first of all, the degree being odd means we're either going to go down to the left or up to the right, or up to the left and down to the right. So it's going to be opposites. And the leading coefficient being 1, being positive, tells us it's definitely going to be down to the left and up to the right. So we can go ahead over here to our graph and we can kind of sketch in those arrows. We know we're going to be going down to the left and up to the right. Now this is just a rough estimate. We may have to change where those arrows are, but that's just an indication of what's going on overall at this point. So the next thing we can use to help us sketch this graph is we can find the zeros. Now the zeros are just found by setting each of our factors equal to 0. And so if we set x minus 1 equal to 0, that's going to give us x equals 1. If we set x minus 2 equal to 0, that's going to give us x equals 2. And if we set x plus 1 equal to 0, that's going to give us x equals negative 1. And so what we can do is we can go ahead and put a dot at each of these values on the x-axis because our zeros are the same things as x-intercepts or as roots. So we're going to put a dot at x equals negative 1. We're going to put a dot at x equals positive 1 and a dot at x equals positive 2. So those numbers on the x-axis. Now what we need to do is we need to look at the exponent and figure out what the multiplicity for each of these zeros are, because if they have an odd multiplicity, it's going to cross the x-axis. If it has an even multiplicity, it's going to touch the x-axis but then turn back in the direction that it came. So starting with let's go with our first factor, the x minus 1, well that's tied to the x equals 1, and that has a multiplicity of 1, and 1 is an odd number. Therefore, we know we're going to be crossing the x-axis at 1. So we're not really sure which direction it's going to be going yet, but it's either going to be this, or that way. So I'm just going to put an x for the moment. We'll come back to that in a second. So now let's look at our x minus 2. That's connected with the factor x equals 2, and it has an even multiplicity. And so what that means is we're going to touch the x-axis, and we're going to turn around and go back in the other direction. So we can now see that it's going to do something like that, because we know that that's the last place to the right that we run into the x-axis. So we can go ahead and connect that to our arrow. That also tells us which direction we're going to cross the x-axis at the x equals 1. We know that we're going to kind of swoop back up, and then we're going to cross just like that. So now let's look at our last factor, the x plus 1. That's connected to the 0 of x equals -1. And here we have a multiplicity of 2. Again, you can just peel off the exponent. That tells you what the multiplicity is. And so what that means is we're going to touch the x-axis at -1, and we're going to turn back, so it's not going to cross. So we can go ahead and connect that to our arrow in the bottom left-hand side. And so now we know just about everything about this graph, or at least a rough estimate of it, except for we don't have this little middle section right here. We need to figure out what happens there. And to figure out what happens there, we're going to find our y-intercept and put a dot and then connect everything together. So now to find a y-intercept, all you have to do is put 0 in the place of x and solve. So all that's left to do is evaluate the f of 0. And if we put 0 in the place of x, we're going to have 0 minus 1 multiplied by 0 minus 2 squared multiplied by 0 plus 1 squared. And if you multiply all that out, you're going to get -4. And so that tells us we need to put a dot on the y-axis at -4, because that's the y-intercept. And now we can connect everything that we had. And so if you sketch this in your if you graph this in your calculator, or maybe on Wolfram Alpha or something like that, you should get something that looks pretty similar to this. Again, the idea is really just to learn how to find the end behavior, the zeros, and the y-intercept, but also to see that you could use those bits of information to get an idea about what the overall graph looks like.